Yeah, I can spice this beginning up. Okay, so this is our Stratocaster's final presentation. We're here with Minsu, and then we have Tyler and Jack here. So yeah.
So our project is basically a synthesizer and transcriber. The synthesizer has some features that where you choose like an instrument and you can play back, the song that you input in the timbre and the amplitude of that instrument. And it also can transpose from key to key, including major to minor. It can change modes. The transcriber key features. It can detect the key basically by calculating the percent error when it comes to the percentage of how often each note occurs in the song compared to a database.
Yeah, the key distribution.
Yeah,
Yeah.
and then it can play back also uh, this song. The GUI has drop-down menus, it has file import buttons, synthesizer button that opens a new GUI, and it also, it connects two GUIs together. And then the export button on the synthesizer GUI writes a new song file that you can then use in the transcriber. So basically, first you start the program, it takes in a file, or you can click the synthesizer, which then reads in a new file. Then it does the key detection, it reads the pitch of the note, it reads the durations, it can do the key detection, and then you can change things like the clef, the pitch, the instrument, and then basically you click the transcribe button and it transcribes it onto sheet music.
Yeah. So let's talk about who is this for, right? So the use case. So I think that this is like a learning aid for beginner instrument players, people who are just learning to play the instrument, who would like some sort of assistance, kind of hearing it being played, maybe at a slower tempo, so that, like they can follow along. And we think that like this kind of like the value of this product in the marketplace is like pretty high right now. Interest in learning instruments, it's been reignited with like the pandemic. Everyone's like suddenly been spending a lot more time at home, and so a lot of people are like, "Hey, I'm gonna pick up that instrument that I dropped when I was in third grade." And so, the interest has been reignited, and so people are going to be interested in this kind of thing. And we think that notwithstanding, playing an instrument is extremely beneficial, right? Especially for younger students. It fosters neuroplasticity, so that can be applied to like basically just everything else that they're going to do in their life, not just music. It also builds discipline and practice habits, and also it's pretty cool to be able to play instruments. But the big thing is that 50% of students quit lessons, right? So, and that's pretty bad. They're not going to get any of those benefits if they're not playing the instruments. And the strongest factor for quitting the instrument, many students cited, was just like a lack of interest, right? So a lot of these students are forced to learn classical pieces, right? And classical music is great, it's beautiful, but a lot of younger students just like aren't really that interested in that kind of thing, right? So we think that like kind of maintaining this interest and like retaining this interest is really really key to like keeping kids with this like with this program for an extended period of time. And so the reason why we chose anime as the specific spin for this project was because it's just like a really popular thing these days, right? So 44% of American teens are fans of anime. That's like a lot of kids, right? And it's one of the most popular genres in television, especially among younger audiences. And so because of that, there's going to be a large overlap between anime fans and then like young instrument players. So if we take advantage of this overlap, it caters to these students' existing interests and helps retain participation. And also, anime music is characterized by these really powerful, bombastic melodies. So it makes it beginner friendly to learn and play. It's not like super intricate in the harmonies.
Okay. We had a testing for our prototype. So first, kind of the most important thing to get started on was the GUI, and so we made sure that it ran, that it was able to export correctly, which it did. And then we tested our method for determining the key. So we fed it a sample of songs, make sure it could identify the key correctly. So we ran 24 tests for 24 keys, and of those, it was able to identify 14 correctly, which is about 59%, I believe. Uh, and one challenge was to find multiple songs for testing because uh, for like some keys, there's not really like that that widely used today, especially in music that we're familiar with.
Yeah, in general, also just finding like pieces that just have like the one instrument playing that are
Exactly.
feasible for us.
Right. So for autocorrelation, so the way we tested that to make sure that ran well was we plotted the MIDI numbers from the autocorrelation to make sure that these numbers actually were what they're supposed to be. Uh, and then to test out the enveloping on each example instrument, we looked at the graph of the signal that we got, and then the graph of the sample, I guess. So for guitar, so make sure that the envelope correctly fitted to the sound, and that it tapered off as it should.
And here's just a presentation of our key detection data. It's a pretty simple graph, right? But you see 14 of the tests were correct, 10 of them were incorrect. Yeah. And
For the final prototype analysis, our GUI is working. We are able to link them together. Everything works. All the buttons are working. The key detection, obviously, 58% accuracy is not perfect, but with the difficulty of just counting all the keys, making a database, it's hard to have enough data to make it more accurate. With more time, we could also explore other methods, such as the hidden Markov model.
yeah,
The autocorrelation is it's pretty good for like middle of the range pitches, like maybe from like the second octave to like the sixth octave of the piano, but like the extreme lows and highs, not the best. And then with enveloping, it's very good with a 4/4 time, but out of other time signatures, it's sort of difficult because the math is obviously a little bit different for triplets and 6/8, for example.
yeah, and so that puts a couple of restrictions in the kind of like songs that we could put into our transcriber, right? So, most of the songs have to be, single instruments, not as many like, chords. It's like we struggles with that, and like the time signatures, obviously, a restriction as well. And there's just some citations, and yeah, that's our presentation. Next coming up is going to be our demo.
Hey guys, today I'm going to be showing you our demo. So first we have our transcriber GUI. We're going to click on the synthesizer, which pulls up a pretty standard synthesizer, except we added a few changes to it. We have a note duration. You can change into a whole, half, quarter, whatever you want. We're going to play a few notes here, and then change to half notes, then back to quarter, then into eighth notes. And then we also have an octave up and an octave down. In this case, we're going to go octave up. Then back down an octave. And to quarter, half note D. Yep. And then we also have a tempo slider, which you can change tempo or whatever you want. Yep, and that's our synthesizer. Next, we have our main transcriber menu. We can choose a .wav file. Yeah, it automatically adjusts to whatever key the WAV file is in. Because due to our database, we have a note distribution that's in our code base. Again, it automatically adjusts to whatever the starting key is for the .wav file. You can also change into different instruments like violin or guitar. In this case, we're just gonna use trumpet. And you can also change into whatever desired key you want. We're just gonna keep it at major, A major, and yeah. And here's we're gonna click on the transcriber button, which does all the magic for us. Yeah, as you can see, there you go.
Let's go, dude.
Yeah.